So we're going to have another look at a question from the advanced mechanics topic. So we're told a student throws a ball directly upwards. We need to identify the sign of the position, the velocity, and the acceleration in the following instances. So we'll draw a little diagram of this. There's a student here, they have a ball, they throw it upwards, and then it sort of travels along some path. We'll assume that they throw it directly upwards. Goes up here, and then at some point later it comes back down. So what is the position, velocity, and acceleration after the ball is thrown? So we're going to assume that the position, we could assume a few different places where the position begins. I'm going to assume that the position is the ground. So position equals 0 is the ground. So we need position, we need velocity, and we need acceleration. So identify the sign of the position after the ball is thrown. The position is positive because it's above the ground. The velocity is positive because the ball is moving upwards. So they've just thrown it. It has positive velocity as it moves up. The acceleration is negative. And the reason the acceleration is negative is the only acceleration exerted on the ball pretty much is gravity. Gravity points downwards. Down in the y-axis is considered negative in this case. Now if we look at question B, at the ball's maximum height. Okay, so the position is still positive. It's still above the ground. The velocity, however, is neither positive nor negative. The velocity is actually 0 because the ball has stopped, right? It's just reached its maximum height. The velocity was positive as it was moving up. Then it just sits there for a second. Then when it starts to fall, its velocity becomes negative. So here velocity is actually 0. The acceleration is still negative because the only acceleration exerted on the ball is gravity, and gravity points downwards. So acceleration is still negative here. And then in case C, just before the ball lands, so just before the ball lands, the position from our reference frame is still positive because just before the ball lands, it's still above the ground, right? So its position vector is still slightly positive. The velocity is now negative. So the ball is now going down. If it's moving down, the velocity is considered to be negative. And the acceleration, as has been the case through the whole question, is still negative because gravity is still the only acceleration on this object. Gravity points down, gravity is negative. So after the ball is thrown, the position is positive, the velocity is positive, the acceleration is negative. At the ball's maximum height, the position is positive, the velocity is 0, and the acceleration is negative. And just before the ball lands, the position is positive, the velocity is negative, and the acceleration is negative. Now these answers will vary slightly depending on where you put the reference point for position. So in this case, position was on the ground. That was my choice. I structured and wrote this question, so I get to pick where it was. But if your teacher specifies, in the person's hand is the position, then by the time the ball hits the ground, its position will be negative. Because if the person's hand is the reference frame, being below that level will actually be negative. So you've got to be very careful to make sure you're providing the correct answers within the context of the question that you are given.